Welcome back to the lecture series on Python programming specialization. In the last few lectures, we have discussed various Python data structures like lists, tuples and dictionaries. In today's lecture, we will be discussing another interesting data structure offered by Python, that is sets. In this lecture, we will see how do we create set data structures, and then how do we access the elements from the sets, how to iterate over the elements, and then we try to get an understanding of what are the advantages of using sets over the lists or the tuple data structures. So let us start our discussion with getting an understanding of what sets are. Sets are basically unordered collection of objects, that is, there is no ordering among the elements in the set, and the objects could be of this homogeneous type or the heterogeneous type. Hence, set is a compound data structure. Moreover, elements in the data structure cannot be repeated, that is, duplications of elements is not allowed in the sets. Moreover, set is of mutable type, that is, it is possible to add the new elements to the set, and also it is possible to remove existing elements from the set. Remember one thing, set is the mutable data structure, but the individual elements of the set are basically immutable, that is, every element by itself must be immutable. That is, you can have the elements of the set as only strings, numerical types, tuples, etc., which are only immutable type. Mutable types like lists, sets and dictionaries are not possible to be of the elements in the sets. Here you can consider an example. Set S1 is the set data structure with all the elements are of type immutable. You can consider the set data structure is similar to the mathematical set that we have studied in your 9th or 10th standard. Now let us see how do we create the sets in Python. A non-empty set can be created by enclosing the collection of elements inside the curly braces and by separating every element by a comma. Or we can even create a set data structure by using the set constructor and by passing an iterator to the set constructor. Here you can consider this example set S1 where it has a collection of elements, a floating point number, a string, an integer and a tuple which is having a heterogeneous set of elements. All the elements are enclosed in curly braces and each element is separated by a comma. Creation of empty set can be possible by using the set constructor without passing any argument and assigning that to the set variable. But remember, when you assign the empty curly braces to a variable, then that variable is treated as a dict type rather than the set type. So you should be careful while creating the empty set. You can create an empty set by using the set constructor without passing any argument, just as shown in this example. Now let us see various example sets. Here is an example of a homogeneous set with all the elements as integers, which represents roll numbers of the students, which are integers. And here you have another set which is again a homogeneous set where all the elements are of type strings, which represents the courses offered by computer science department. Now you can observe a heterogeneous set. So here S is a set which contains integer values, floating point elements, moreover boolean values, tuples and also strings. All are of immutable type, but they are all different types. That is how we can create the homogeneous types and the heterogeneous types of sets. A set can be created by passing an iterator like a list or a tuple to the set method as shown here. Here we are passing a collection of elements like which represents the days of a week as a list, and we are passing that list to the set constructor. That is how we can create a set by passing an iterator to the set method. So we already discussed that sets do not allow any duplications of elements. Every element must be of unique type. So here while creating the set, I have assigned multiple elements with the same values. Here 2 is repeated twice, 4 is repeated thrice, 5 is repeated twice. That is how we assign these values while creation of the set. But even then, after creation of the set, S1 will be created as 2, 4, 5 with the elements in the set S1, which contains only the unique elements. All the duplications are removed while creation, even if you pass the duplication elements to the set creation. Consider the creation of this set S3, where I am passing a single string Python programming. Now only one single element is available in the set S3 and the set S3 is created. But if you use the same single element and if you call the set method and if the string is passed as an argument to the set constructor, so S2 is now created as a set with individual characters as elements. Please try to observe the difference between creation of the set S2 and the set S3. S3 is created by enclosing a string within curly braces, so that element is treated as a single element in the set S3, whereas while creation of the set S2 we pass the same string Python programming, but we pass it as an argument to the set constructor. That is how it is considered as every character in the string is treated as an element and the set S2 is created. We know that lists and dictionaries are the mutable data structures, and set is a mutable data structure, but every element inside the set must be of immutable type. That is how a set cannot have the immutable types like list, dictionary. Even a set also cannot be part of another set. That is how if you consider the set creation S1, it is invalid. The reason is we have 10, 20, which is a list, as an element in the set S1. That is how it's not valid to create this set S1. It generates an error. Moreover, it's not possible to have a set as an element in the other set. That is the reason why it is not possible to create the nested sets. The reason is simple. Every element inside the set must be of immutable type. That is how 10, 20, which is a set, is not valid when you pass it as an element to the set. Now let's try to understand what is the advantage of using sets over the other data structures like lists and tuples. So basically there are various advantages of using sets. Efficiently we can remove the duplicate elements from other data structures like lists and tuples. Here you can consider a list L with duplication of elements. So 10 is repeated twice, 20 is repeated, and 30 is also repeated. So now I am going to create a set S1 by passing this iterator, that is list, to the set constructor. Then S1 is created as a set, but all the duplications are removed. Just with a single line of statement we can remove all the duplications in the list. So that is how sets can efficiently remove the duplicate elements from the list or tuple. And moreover, sets can efficiently do the membership testing, that is checking whether an element is present in the set or not is easy in case of sets. The reason is sets uses the hash table as a data structure to do this operation. That is how sets can efficiently check the membership of an element in the sets. Moreover, various set operations like union, intersection, difference, all these operations can be performed very efficiently on the sets. That is how it is much beneficiary to use sets over the lists and tuples for removing the duplicates, to check the membership of elements in the set, and also to apply various operations on the sets. Let's see how can we access the elements from the set. So consider the set S1, which is having collection of string as elements. Now if you want to access the entire set, then you can refer to its name to access the entire collection of elements. So when I use S1, then I mean that I am referring the entire set of elements inside the set S1. But it is not possible to access individual elements from the set, as there is no indexing possible. Sets are basically unordered collection of elements. There is no ordering among the elements. That is how it is not possible to use the integer indexing to access any specific element from the set. And there are no methods also that supports to access individual elements from the set. But it is possible to iterate over the sets. Now let's see how do we iterate over the sets. Similar to the list and tuple, it is possible to iterate over the elements of the set. So this is the general form you can use. So a for loop with the set you can use to iterate over the sets. So here is an example, my set S1, and I can use this code snippet for value in S1. So print value. That is, I am iterating over every element in the set and I am processing the set of statements using that value. For the first iteration in the for loop, the value gets the first element from the set S1, that is C. In the second iteration it gets the value C++. In the third iteration it gets the value Python and executes the set of statements whatever is included inside that for loop. Here I have only the print statement, so that statement would be displayed. That is how we can iterate over the collection of elements in the set. So in this lecture we have discussed what sets are, what is the advantage of using sets over lists and tuples, how do we access the individual elements using the for loop, and then we have seen various ways to create the set data structure in Python. Thank you for watching this video.